Hi guys. The easiest, fastest, cheapest way to make this look like this, somewhat cheating, but that's the truth. The easiest, fastest way to turn this into this was also the cheapest way. Now, I really did try to save these. These two here, they look like this when I started. And I brushed them off and got them all nice and slick. And then I started thinking, how do I protect this so it doesn't look like this again? Well, the obvious choice was oil. But I live down around Houston, Texas, where it's humid all the time. And even though the shop's climate controlled, if the power goes off, in fact, this has still got some rust started on it. So that was out. The next step was taking these to a chrome plater. And I called 4 different places around. 2 of them didn't even want to talk to me about it. One of them gave me a price for $100 to do this. So there's $300 plus this and this. It got expensive. Thus the reason why this was the easiest, cheapest way to do it. $100 plus me getting it ready and polishing it and getting all the scratches off to $55. Nickel plated, I think. I don't think this isn't chrome. This has got to be nickel plated. Just, you know, $160, $300. It was kind of a no-brainer. I would have done it, but it just cost too much to put the chrome on. Nickel, they didn't even want to do that. Now there are some kits you can buy. Caswell or Coswell makes a nickel plating kit, but even a small one with not everything I would need to nickel plate these was going to be $300. So I don't know what I'm going to do to these yet. I might buy nickel plating and try that just for the heck of it. But for now, these 2 things are the only thing that'll be prone to rusting. So that's where I am on that. These are all off of the Bridgeport I'm rebuilding. And they look really nice. And dadgummit, if I've gone to all this trouble to paint this thing and all the hours and stripping and painting and costing that, I just couldn't bring myself to put those on. Even though they would look nice, it's just the economics just were hard to beat. Now there's one thing that I want to show you. Let me shut this door. That we're going to have to make. You're not looking up there. Hey, my eyes are up here, guys. Come on. This is a piece that goes into the knee of the Bridgeport. In fact, this handle pushes against this and forces it up against the dovetail on the column. So as you screw this in, this locks it up. Now this Bridgeport's a little different. I'll take you in there and show you in a minute. The problem is I only have one of these. I don't know if somebody's taken it out of the machine before I got it or what they did, but there was only one. That's unless Don played that old cat and mouse game of, you know, when you're putting together a jigsaw puzzle and somebody pockets the piece you need to finish, right? Don wouldn't do that. No, he wouldn't. I sure asked him. If you look on the H&W parts page, this little piece is not shown on the base diagram. So I called up, I needed some other parts, so I called and said, hey, I need one of these. And there's no number for it. So she went, the nice lady, the people try to help you there. The nice lady went and talked to Barry, the guy that does all the videos, and he says she uses the same ones as on the rest of the machine. Well, in my machine, the rest of the ones are a ½ inch shorter in length than this one is. So that ain't gonna work. Now this is pretty simple. It's 400 thousandths or 13/32 diameter. I took a file and tried the file test to see how hard this was. And I could make a little dent into it. It's harder than, you know, just regular run-of-the-mill steel. But it's not as soft as that is. So I wanted to try to get something the same material to make this. It's got a 50-degree angle on the end, and then it's flat on the other end. So it's not hard to make. I just got to cut that 50-degree angle. Now, I have one for a pattern, or I would have been trying to use those short ones. I'll show you where this goes in a little bit. But first, we got to make this. Now, this piece is the piece I need to make. Couldn't buy one easily, and it's such a simple piece, I just said, forget about it, I'll make one. The problem is, how do you make something? You know, that's all a part of every trade, how to do something, whether you're a plumber, a carpenter, a machinist, a dentist, a brain surgeon, is how do you get to the final part? Now, I thought of one way real quick. I had some stuff, I was going to take some stainless steel rod that I had and put it on old Bob, whittle it from a ½ inch down to 400 thousandths. That's cool, I got the shaft. But I needed to go to the tool store anyway, so I ended up picking up a piece of drill rock. And there's a number of reasons why I decided to spend the $8 on a piece of 13/32 drill rod. And can't walk and chew bubble gum at the same time anymore. This drill rod is water hardening, and it's got a very nice surface finish on it already. So I don't have to worry about it sticking up in the bore of this where this goes. It's harder than most regular steels, and if I needed to, I could make it even harder by going through and water hardening it. But I think it's going to be just fine at the hardness it is. It's got a nice finish on this, and so basically all I have to do is hold it so I can put that angle on it and then cut it to length. Let me go find something. I'll be right back. Sorry I haven't been putting out very many videos. The hurricane that went through here, I think the last time you saw me was trying to cut one of these. I hit the saw switch and all the lights went off for 5.5 days. We have a generator, but I don't have one in the shop hooked up, so I was so busy fixing people's gates for the last couple of weeks, I don't know what to do. But now I got a little time, I need to get this Bridgeport done. So I needed to measure that angle. And how can you do that? Lots of different ways. But frankly, a long time ago, I bought one of these. And I know, it says Husky. It doesn't say Starrett on it, but for what I've ever used it for, it's close enough. And basically, you can take and put this angle right here and go up against that. So now I've got a measurement, it's 50 degrees. So I know the angle is 50 degrees. It's not 45, it's 50. If I were to make this a 45, like most people think dovetails are, it would touch and not hit the full surface. So how do you make a 50-degree angle on a round piece of metal and get close? One of these is the way I'm going to do it. I'm going to cut it on my vertical bandsaw back there, but I need a way to set the angle to 50 degrees and firmly hold this rod. This is a 5C collet. Goes in this little block, and you turn this and it locks the collet, the material in the collet. It draws it in and locks it. Then I've got a nice 90-degree surface that's parallel to this area that I could clamp down to my table, adjust this to 50 degrees to the saw blade, and take a cut. Then I'll have two pieces to practice with. That's how I'm going to cut it. I'm not really sure how I'm going to finish off the face of this. It's not a ground surface. I could still see cut marks on it, but maybe just touching it up on the side of a grinding wheel will be enough. We'll see. So that's how I'm going to do this. The next question is, unless I were to take and put like an adjustable base vise clamped onto my table, I've got to have some way to measure that 50-degree angle. The adjustable vices usually have it inscribed on the bottom, but that means I've got to set it up to perfect 0 before I can turn it to 50, and I've got to do all that, and it's just going to take too long. Plus, when you put a vise on that table, you've raised up the distance from the base of the table to where this is going to be, and that could add wobbly factor into it. So I want to keep it as low the table as I can get easily. And this collet block will allow me to do that. I can put this on the table, put a clamp on top of it, adjust it, tighten it down, and cut it. Still need to figure out that 50-degree angle on a table that doesn't have any markings. So that's where I walked over to my Bosch miter saw, which can do more than 45-degree angles. It goes up to 50 easy. So I put it on 50, took a piece of scrap 1x4, came off of a set for the theater, and cut a 50-degree angle. So now I have a piece of metal with the same angle as this board. I can use this board with its straight edge to line it up perfectly on the table slots, clamp the thing down and go. So that's what we're going to go do. Now this is my 26-inch dual bandsaw. It's got a hydraulic table, so I clamp things to the table, and then the table feeds automatically. It'll even turn like this automatically if I wanted to, but never have used that. Needs some work done on a few little things, like the air pump needs rebuilt, but frankly got shop air, so I don't see the really need of doing that. So now we need to align this collet clamp at a 90-degree angle, or excuse me, a 50-degree angle to this table. And I need to get it up here close so I don't have a lot of stick out back here of this rod. I'm going to leave the rod sticking out here so I have two pieces I can use to make this happen. I need to raise this up a little bit. Now, that's going to be a little bit low. I think that may be a little bit high. Yeah, so we'll go one in the middle. I could use my new tool here. You know, I still have that Camelback drill over there for sale, But I was using my closing drill the other day and needed to hold down something. And I looked over there and I saw a clamp on it that looked just like this. And I said, hey, I'm not going to give that away. I need that. And it fits my closing. And I liked it so much, I went searching for this company that made these. These were made by Armstrong before they went out of business. They don't make them anymore. I found this one on eBay, and it's the last one I've been able to track down. They clamp down to your table. I've got a spacer under here, and they're really handy. So if you find one, pick it up. I've even started talking to Clark about building these. They're long out of patent, and if you can't buy them anywhere, this would be a good thing for Windy Hill to make, don't you think? Let me know in the comments. All right, so here we go with this. I want this part to be lined up at that angle. I cut the same angle on both sides so I can line this part up with my T-slot, and that'll allow me to have this angle. Need to come down some. There we go, so I can get a little bit closer. Line this angle up and this angle up. Let's just go ahead and run you down. If it'll go down that far, it might not. Got this flush back here. So if I put this here, I will get the same angle here. Now all I need to do is tighten this block down. And this one's got a ring on the back. You put a spanner in and you can tighten it. Let me go get a spanner. I'm back. Did you miss me? Let's see if I've got one that'll fit here. Well, of course that one won't, and that one's too big. Crap. Now I got to buy another tool. This just unscrews from the back here. Let me go grab something. Just goes to show you, you can have every tool man knows about and still not have everything. I'll put this like this. Make sure we got it back where it doesn't hit the block. This is still lined up. Well, that's not the right one. I wish they'd make T-slots standard on everything. I got so many set of hold downs running around with every table. The drill press, this table. Used to have a more jig bore. It used a weird one. Just a little bit of everything. Put the step block on the back. Make sure that's lined up. Make sure this is at the right angle. It's far enough back. And then to lock it down, I got this old handle that came off something. I have no clue what it's off of, but it ain't gonna work either. The noise you hear is the rotary phase converter, 10 horsepower going up on the mezzanine. Reach around here, turn it on. Put it in forward. Got it up there close. We're going to let it feed slow. Back it up. Turn it off. Burn your fingers. Yow! Kind of a anticlimactic cut, when you say. Didn't shimmy, didn't shake, didn't go anywhere, didn't throw things across the shop floor. And hopefully, as soon as I can pick it up, we'll see if it's got a good enough angle on it. And I always figured I could just touch it up on the bench grinder. If it's not. But you could take this and bolt it to the surface grinder and run it across the surface grinder and true up that face. It does need a little work on it. Kind of got a little bump on the bottom. But I think the other one might have a better off-the-cut finish to it. Let me go see. this is what the angle is here, 50.06. See if this comes close. Of course, that needs a little more. Well, that's not even anywhere close. That's a 44, 43 degree angle. I wonder why. Get the old improvising pin wrench out. See what this one says. Zero this. That angle's quite a bit off. So that leads me to believe that this angle is probably quite a bit off. When you think, so that means the guide over there on my saw is quite a bit off. So what I'm going to do, I'm going to use this gauge to scribe the angle onto this board, and so I can make sure and just completely eliminate that other miter saw gauge. Let's see if this is the same. Yep. So all we have to do to transfer that is to put, my God, that's off. I haven't been drinking. Once again, this is probably Don's fault. Let me go do this, I'll be back. I went over and I just used my gauge as a regular old gauge. Butted it up there, got it to the right angle. Took this, transferred it over here on a line to this angle, cut it, and now we're going to put it on here and get it lined up using this straight piece here, getting it even with the edge of this T-slot. That's what I use on this table to get the angles right. And so this needs to come about right there, so that'll be good. Let's get this good. It's going up a little bit. It's in gear as we're talking. It's just moving very slow. Sorry about the flicker, and I stuck another bulb in here, and it's a filament bulb. I've been trying to use them up. And it shakes too much and makes it think you're having a seizure. Turned it way down low speed at the very end with very little force. Reverse. Off. Gloves so I don't burn my hand. Well, y'all can't see over there. This is a radio show again, huh? Let's put you up. Let's see. Aha! Perfection that time. I think that's going to do pretty good. Put a little bevel around the edge of it, and it's got a nice smooth surface. Now we'll just cut it to length. Now to cut it to length, we're kind of going to do the same process, only we're going to reverse. Instead of using this for an angle, we'll use a square to line up that block. So go in like this, and because I can't let that big rod clear that way, I'll turn it around. Like so. And what I'm going to do is put this in here so it balances my block so it doesn't rock on me. Put it about there. Move you over to the other side. want these blocks on these notches to be pretty much level. A little bit higher on the front where it touches here, but you don't want a big angle because this nut has to rest flat against this or it can move it. So now we've got you kind of sitting there. Now use this square to line you up. Like so. Looks good. And then we'll use this as a gauge for how far we want this to stick out and be cut. And I'm doing it this way because I know exactly where the saw blade's going to be when it cuts it. I could just put this in and stick it in and scribe it and do it another way, but I think this is going to be plenty accurate enough for what we're doing. Using the old Mark 1, soon to be Mark 43 eyeballs. And it's kind of hard to sit there and do this. I don't know if you could see what I'm doing. Let me see if I get a better angle. Now, before I get yelled at for having 1, 2, 3 blocks that look like this was a set of maybe $5 a piece, but they're great for doing things like this, where you need a stop to gauge the length. You just don't put it in the hole. And I'm looking down the side of the saw blade to the end of that, which I'm holding up level against this. And that's it right there. Now that's not a critical dimension either, mainly because your screw screws against it. And it can have a little, I mean, it could be off 20, 30 thousandths. Okay, let's tighten this up. That's enough. This collet's grip pretty good. Let's turn you on. Excuse me, got to reach around you to hit the button. Pardon me. Then we're going to set a little more force on it. How's that? Can you see? Surprised you couldn't buy that easily on the web. And another thing about this is, when I was asking about it, they asked me if I had one of these. I'll tell you in a minute. Got it turned down to almost no force at all. That's it. I think that's good enough. I kind of took a little more off the edges so that if the screw hits it, it doesn't mushroom it out. So a little, who knows if it'll help. But before I do that, well, we got all this, the converter and everything running. If you watch back on the last video, I was preparing these to be alignment pins for the head of the Bridgeport turret. And the doggone thing needs to be finished. Now the reason, I've lost my set I made a long time ago, but what I do with these threads, they're just 1/2 inch by 13, is I make them long enough to go all the way through and stick up out of the spider to where you can put them on the turret, just come down over them. But once you get them in there, then you want them out. Well, I just put them in finger tight, but I've had one jam before. So what I do now is I take and put a little slot with a saw blade in it, so I can put a screwdriver in there if I have to twist it out. Doesn't take a minute, but it's an extra little bit of insurance. Get a thin bladed screwdriver in there real easy. Now this is just a little added protection in case it gets jammed. Then I take and put a nut on this end, and where I cut it, I put the threads on the grinder to make it where it starts easy. This grinder's got such good bearings, it's still going. It'll run for 4 or 5 minutes. If you leave a nut on it, even if you mess up the threads a little bit there, when you come off, it cleans them up. Well, if it'll come off. That's why you put the nut on it. I'll pull that one off. Well, it's got to come off because I need it on the other. There it goes. So now that'll start a thread easy. Well, as you can see, I'm back over here by the Bridgeport. Those little rods threaded rods I was making, going to be used as alignment for going into this spider. You can screw these in. There's a spider in here, and that'll give you alignment when you're sitting down the top of the turret onto it. That's why I used to do it all the time. I tried doing it with Dawn, and boy, did we screw it up without those. These little pins go in these holes right here on this side, and they fit into the dovetail like this dovetail, and they go up against that dovetail like here, only on the back of this column. So these will go in here. And I pulled this all the way up so I could get to the bottom of these. I thought sure I could buy one. So I had put this one in before we lowered this down. I had to pull it up to get it all out. But this is ready to go down. I got all the parts ready to put this on. Next time we'll be working on getting this in and finishing up the turret. So thanks for watching. Hope you don't think this is too simplistic. But it's another way of getting things done. Cheers. Time for a non-alcoholic beverage. Thanks for watching. Damn, it's good.